All right, everyone, welcome back to the afternoon session of the 2024 Haskell Symposium. Hey, if you haven't signed up for a lightning talk, just Google Doc. You could do that. Whilst you're doing that, though, we'll hear about the state of GHC, and Simon Peyton Jones needs no introduction.
Okay, thanks. So this is going to be very sort of interactive, I hope, not just a monologue, because I feel as if I'm speaking on behalf of a small army of people who've done all the heavy lifting, and I just sort of run around tying up loose ends. So please feel free to intervene. Now there's a microphone here. There's one here, and just sort of maybe just sort of hand it around, so you don't have to physically come up. You can just grab it. So maybe Pablo, Pedro, sorry, would you just keep an eye on everybody and throw the microphone to them? It'd be much more fun. But the reason for the microphone is not so much to be heard in the room, but because remote participants won't hear us at all if we're not using the microphone. So it's polite to them. Okay? Where are we in GHC land at the moment? Well, let's start with the releases of GHC that have happened this year. Just to remind you, there is now a the GHC status page that's meant to tell you an up-to-date story about what releases are happening and what releases are planned. So, and it really, last edited by Zubin a week ago. This is actively maintained. And up here, you'll see in the sort of, there's a row here for each release. And in the column next planned release, these little links here go to the milestones for those release, and the dates for the release are on the milestones. You have to follow one more link to find anything about dates and schedules. Okay? Let's see. So here's our current story about releases. There's a 9.6 seems to be a fairly stable iteration of GHC. So we released 9.6.6 in July, and I think, tell me if I'm wrong, anybody, I think we're planning to continue to, this is in a pretty stable state, but I think we're planning to continue to support that, unlike 9.8, which turned out to be a bit wobbly and was rapidly overtaken by 9.10. Zubin.
There might be one more 9.8 release, but not too many.
Okay. So it might be one more 9.8, but sort of 9.8, don't leap to 9.8 unless it's a stepping stone to somewhere else. 9.6, you should be fairly safe, is that right? Yeah, okay, good, thank you, Zubin. 9.10 actually came out in May, so I'm going to tell you a little bit about what's in that. And 9.12, we're planning to forking the tree soon, like in September, and planning to make a release in November or thereabouts. I'm going to tell you a bit about what's going to be in that as well. So that's the sort of plan for the release schedule. Still currently 2 a year, and we're trying to be transparent about which ones we're then thinking, okay, we're not going to keep patching that. The trouble is we can't maintain too many active branches at a time. There just isn't a sort of maintenance, it's a maintenance burden to make releases. So we're trying to be clear about what we're not doing. Okay? So let's see. So new in 9.8 stroke 9.10 because both 9.8 and 9.10 have come out since last year, right? So essentially, these are the kind of the biggest new features in the last 12 months since the last Haskell implementers meeting. So what's this? Quite a lot of all of the 9.8 and 9.10 stuff is really to do with consolidation, I think. It's sort of filling out the design envelope of what Haskell is to make, to fill out design corners that were sort of not quite there. So this visible for all thing is one of them. This is sort of, it's moving in the direction of dependently typed languages, but without moving to full spectrum dependency. So GHC still has a complete phase separation. There's no doubt about which are type parameters and which are term parameters, but there's a bit more syntactic flexibility about what you can say where. So, have you all seen this? You can now say in a type signature for a function, you can say for all a arrow AROA instead of for all a dot AROA. And what difference does that make? If you're in the core language, it doesn't make any difference at all. It's still just an ordinary old for all, really. But the difference is in the source language that you now, at a call of this function RID, you must supply a type argument. It's like as visible an argument as any of the term arguments. So here's a call of RID, and you apply it to a type, in this case int, with no funny @ sign, right? It's not optional. It's a compulsory parameter, like any value parameter. Must be there, okay? In pattern matching, you can pattern match on T as well in the left-hand side of the function, if you want. So, here you can see that here I'm applying RID impredicatively to a polymorphic type. So you can already tell that, hang on just a second, but you can already tell that when the parser and the renamer are looking at this, they're looking at int and for all AOA. And at the moment, the parser thinks that looks like a term to me. So we've had to embed for all into terms to begin with. And later on, when the type checker gets to it, it says, I know the type of RID. This is really a for all. So this first argument must be a type. And it sort of walks over it and checks that it doesn't contain case expressions or something. Yes?
I'm mostly wondering what the lambda syntax is. Will this be big lambda, so / /?
We're going to get to the lambda syntax is where's the lambda syntax here?
Oh, okay, /
right?
at. All right, thanks.
So you say, so yes, if you want to, instead of doing this on the left-hand side here, you can do it on the inner lambda, and it is lambda with an at. And there's a little thing here. If you write lambda at without a space, that's some kind of operator. You have to put a space. I hate that. So put a space there. It's a safe thing to do. I don't know. Maybe you can. Maybe in the end we'll take that out. So I feel as if that's a little glitch, really. Okay. What haven't I said about this? No, I think. Oh, and why is this useful? Well, because for some functions, you know that there are lots of functions that have proxy in their type, right? Why is that proxy there? Is because the author of the function wanted to say, you must supply a type argument, right? I'll call it proxy. So any function with a proxy in its type is a candidate for doing this. And size of here is a good example. Size of has type, now for all a arrow, this is a type class size a to int, and you say size of float. What could be more natural than that? Rather than saying size of open paren proxy : float, or : proxy float, or proxy at float, or something. Much better. Okay? So, so this part is called required type arguments, and these being able to explicitly abstract. Beg your pardon. This part is called required type arguments. Yes. Oh, and I beg your pardon. If now I'm hesitating. If something has a for all type, you don't need the little at, Christian, right? But for ordinary, for all dots, right, you can still write. So here is HR with this type abstraction things. HR has a higher rank argument, right, a polymorphic typed argument. And in its argument, you can now explicitly, just like in the lambda calculus, you can abstract over the type argument. Optionally, you don't have to. You can still just say lambda x's. But if you want to have this optional big lambda, you can. And it's useful because it lets you bring A into scope, right? And here it is being used in the right-hand side. Does that make sense? And so at the moment, in Haskell of yore, Haskell of last year or the year before, often the only way to bring type variables into scope was to use a type signature, and for all variables of the type signature, scope over the body of the definition, right? But we always knew that was a bit weird, right? Because like the type signature could be somewhere else in the module, right? It doesn't even have to be adjacent. And moreover, it doesn't work very well for things like this higher ranked argument, right, where there isn't a type signature at all. So these two, and the last thing is you can do the very same in, as well as the lambdas, you can do it in definitions. This is for all dot, and you use ID at, and in type declarations as well. And sometimes you want to say for all k, and in the type declarations you data t of kind k. Does that make sense? This is all, I see this as all as exploring at something that in principle is not at all difficult. All of these things are there anyway in the core language, right? It's just that in the source language we want to make it possible for you to write them without making it, unbearably cluttersome to be forced to write them all the time. So there's a lot of somewhat ad hoc decisions in this design, but they seem to be working out fairly well. Any observations or questions about this? Andres.
Just a side question about it. Like, if I have scope type variables enabled, then in ID I would already have A as a type variable in scope, right? And now, with the at A, will I get a warning that I'm doing type variable shadowing? Or
honestly, I'm not quite sure. I think you'd probably get a shadowing warning. That's a good question. Yeah.
Or is that a special
you certainly
case?
don't use any, you could say B there perfectly. That would be absolutely fine. But I think if you're using extended for all scope, which is what the for all thing is called, extended for all scope and type abstractions, you probably should get a shadowing warning. You should give it a try.
Okay.
I'm not quite sure, but we now do have two slightly mutually redundant ways of bringing a type variable into scope. But this one, as it were, is the sort of, like, this is the way God intended, I feel, as if, you know. Yes, but type inference does not work with these guys, right? So this is good if you know what the type of the argument is, because it comes from the function. But don't expect to just write for alls and write big lambdas and expect them to infer really well. Yeah.
How does this feature interacts with GADTs? I mean, consider a function which has for all a row and then big X of a, when big X is actually a GADT, for instance, indexed by a list of a's. I mean, I pattern match on the constructor of X, and can I write the pattern of that? It's a list of some a in the left-hand side of this explicit for all?
I don't think I have the program you just described clearly enough in my head now. I think we need a bit of paper. But I don't think there's a difficult interaction with GADTs here.
Okay, so
there is a question about scoped, how are type variables brought into scope by patterns in pattern matching on constructors, right? And that's a whole nother story, which I think hasn't changed very much in this, but I think we may be changing a little bit in the future. Has it changed very much in this? I don't think so. Not by these two features anyway. Yep.
Yeah, so, you know, it's maybe my problem, but if you put a typed hole where it expects a type parameter, what will it do?
So say that once again?
So if you put a typed hole where you would say, you know, int, or, you know, if I say size of underscore.
Oh, I see. Size of, yes, you could say, I think you could say size of, you can certainly say size of, you can certainly use, like in type applications like here, you can certainly say at underscore, meaning at, you know, some type. That's quite useful when you want to omit one of these positional arguments. I'm hesitating slightly for, could you say RID of underscore? I think so, actually.
Okay, because we have partial type signatures that kind of, okay, but interesting.
But then, though, typically, it would be a bad idea because probably, like in this size of, if you say size of underscore, you're back into the original problem about ambiguity, right? But I'm not 100% sure, but I think so. Yep. Okay. Yep. Please.
You gave the example of size of as a good candidate. Do you think that that will ever be part of base, one of these functions that does have the explicit?
So then there's a whole, that gets into a question about stability, doesn't it? So over time, we'd like to move the API of, well, all libraries, right? Any library that is using proxy at the moment might well want to shift to this. And how do you do that in a way that is, goes with the flow of users? One thing, I'm going to talk about stability a bit later, but yeah.
Just in response to Maddie, I think we've made a small design mistake in using underscore both for whole and for thing I wish GHC to infer, and maybe one of them should move.
Well, you have a whole proposal about that, don't you?
I have a whole proposal about something in this space that I haven't looked at in 2 years and probably should be revised.
Somebody else? Yes. Oh, here.
For this visible for all, did you say you could match on the type parameter? And could you? Okay.
Sorry. No. So I meant when I said you can match on this T here, you can't say RID of int this and RID of bool that. No. Right. We're not. We're not passing representatives that we can look at. It's all going to be erased. So it ends up having to be a type variable. Thank you. Good point. Yeah. What? It would be nice, but it wouldn't. But then you'll be going. Now you go to typable, but then you can match on typables. All right. Yeah. And so maybe you want better syntax for matching on things with typable constraints. Write a GHC proposal, but not in 9.12 or 9.10 or 9.8. Right? Yeah, but once you got a typable constraint, you ought to be able to you can do all of that, but it's a bit clumsy, and maybe a bit better syntax. Yeah, please. Oh, go ahead. Thanks.
So does it only work for types, or can I use it also for any kinds? Does it lift to the kind level as well?
Oh, yes, all of these can be kinds as well. Yes, absolutely. Yes. Types and kinds, they're all the same thing. Have been for some time. Thanks to Richard and Stephanie. That's fine. We got, in fact, today I saw, Ed showed me a program in which he actually uses the same thing as a type and as a kind. Scary. I mean, there's a lot of unsafe coerce in the same module. So. Okay. Another big new thing in, that I don't know, does anybody know about this exception backtrace stuff that Ben has spent so much time implementing this year in any detail? So, in GHC, if you call error, then, that makes an exception, and then, the program falls over and just says, error, bad thing happened. But you'd like to know, error, bad thing happened at this place in the program, with this call stack or something. The trouble is we have 4 different ways of collecting call stacks or gathering backtraces, and this exception proposal not only lets you choose which way you'd like to use, but also lets you attach user-defined metadata to an exception. So it gives you much richer information about where exceptions were thrown from. It's quite an elaborate proposal. It spent a long time in the making, but it's actually part of 9.10, I think. Isn't that right? Yeah. So Ben Gamara is the person who put most work into this, spent a lot of time implementing, so thank you, Ben. I think this will really help in, when the system falls over, it's terribly upsetting just to say head of the empty list somewhere in your program, right? No, Leonard, yeah. Oh, yeah, behind you.
Is there a runtime cost?
Oh, all of these things have different runtime costs. That's why there are 4 of them, right? Or maybe it's a trade-off between cost and information. I think one of them is just walk the Haskell stack and tell me, right? That has no runtime cost, but is a bit weird because it follows the path of lazy evaluation. Or there's, Haskell stack, which does have some runtime cost, but gives you something much more sensible. So you have to choose, sorry.
Sorry, just
a
question about runtime cost.
Yes.
So the performance, if the exception does not happen, is unchanged, right?
No, for some of these mechanisms, like the Haskell stack mechanism, there is a little bit of runtime cost regardless of whether an exception is thrown or not. Right?
So if I write an exception, raise exception somewhere, so it has a runtime cost.
No, I think only if you say use this more costly mechanism. I think the baseline case is probably still just like today. You don't get very much information, but you don't pay anything. But you can sign up to paying more and getting more.
Thank you.
Christian?
I guess I can't take the whole hand and abstract over the mechanism. I have to decide at implementation, at where I call error, which method I want to use.
Actually, I don't know. Yeah, Zubin may know. Now you're exceeding my knowledge base.
It's in your main function or anywhere in I/O. You can enable particular backtrace mechanisms.
It's a side-affecting I/O operation, is it?
Yeah, it's side-affecting I/O operation.
So you just say at the beginning of your program, use this mechanism.
And you can enable and disable them dynamically. And so with Haskell stack, whether it gets printed or not, you can choose, but you have to pay for the runtime cost of the extra arguments, whether you enable it or not.
By the way, I love the Haskell stack thing because I don't know whether any of you guys use it. I use it all the time now because it lets you, it's sort of incremental. You can just say, give me a couple of call functions. It doesn't have to be everything. It's not a global flag. You just add it.
I would like a flag that says, put Haskell stack on everything.
That would be cool, actually, yes. Everything in this module, or just everything.
Everything. So when you're debugging and you find something, I don't want to go in and modify a bit here and there and there. Just sort of
I have
bang.
a bit of CPP that says, has debug call stack, and it turns into nothing, or into, yes. Okay. Good. So this is big. Then so there are some smaller things that have happened, like extended literals. This is to do with just being able to write int8 literals or int16 literals. There's a little bit of this. All of these, by the way, GHC proposals. I've been putting the numbers in them mostly. I should have put the number for this one, but the process is actually working. We're getting proposals and implementing them, and they get put in. So this is literals for some of these a richer variety of base types. Deprecated instances allows you to say, you shouldn't be using this instance, right? But the deprecation message comes out if the instance is ever used. So it means that there's a path that says, I intend to remove this instance. You can release a library which deprecates it, and people will be told, oh, it's going to go away. It gives them a little bit more time. But the nice thing is it comes out when it is used. That's why it needed a bit of compiler support. There's a bit of, This is me failing to edit the slide. Bit of name, the namespace stuff is about when you declare the fixity of a symbol, you can say infix L, 6 plus. But did you mean the plus at the term level or the plus at the type level? Or if it's capital K, did you mean the type constructor K or the term constructor K? For a long time, it's just meant, it's tough, you just mean both. Now you can say infix L8 type K or infix L term K. Data K, you say. So, and similarly, when you're deprecating things, you can say whether you're deprecating the type version or the term version. It's all because of the punning that we have and use so extensively, right, at both the term level, that the same symbol appears in both terms and types, right? Such a good idea, such a bad idea. I don't know which, but this proposal, several proposals, and now I think this is now pretty consistently implemented, just lets you say which you mean, if you mean one or the other. Okay? Good. So those are the things that are in the releases you can get today. But the upcoming fork, and therefore the thing we're working on now, what's come since 9.10, all patterns. So this again was a GHC proposal, which Sebastian Graf and David Konther and Ober wrote. These are all patterns that don't bind variables. In the end, the steering committee pulled back from saying, oh, can you have an all pattern that binds multiple variables? These are ones that do not bind any variables. So here, if you've got this enumeration type, you can match on red or pink, and here match on blue or purple. That's quite convenient sometimes. Not very hard to design, not very hard to implement. Took a surprising amount of hoo-ha to get the proposal decided, partly because there is a design space here. Multi-line string literals, this Brandon Chin. Brandon Chin isn't here, is he? I'm not sure I've ever met Brandon Chin in person, but they're very thoughtful and quick off the mark, and has implemented this multi-line string proposal. It just lets you write. You have to start with, I think, 3 quotes and then write a whole pile of stuff. So it's a way of incorporating whole documents inside GHC programs without much trouble. Just one sort of thing you think, yes, convenient, but nobody's ever done it. Now they have.
Yeah, so all patterns, do they only work on enumerations, or are they going to work on arbitrary patterns?
No, all patterns will work on, you can take the ORs of any patterns that do not bind variables. So they can be, you could say just open curly brace, close curly brace, vertical bar, blah, or just underscore. That's fine to put in an OR pattern. But you can't say, C of X or K of X, right? Even if the X's are the same. Yes. Right. Okay, yeah.
Sorry. Could you please tell me, why couldn't you choose vertical bar?
Of course, that was the longest part of the OR pattern proposal, is what syntax to use, right? Why don't we use vertical bar? I have forgotten, but there was very good reasons for it. What? So we're using semicolon, yeah, but why not vertical bar? I mean, all patterns, you'd think vertical bar, surely, right? Okay, you should go and look at the proposal. There was a long discussion about this. There were multiple votes. There were, people died in the trenches. Small children were sacrificed on the altar. It was. Okay.
Came out wrong anyway.
That's right. These are the things you cannot get right. Let's see. Overloaded, records and overloaded dots. So in the end, we sort of converged around this type class has field for overloaded records. So now you can say, but previously, you could only say x dot f, where f is a field of a record, if the field had a lifted type, like int or maybe. Now you can say x dot f, where the field has an unlifted type, like int hash. So this is in effect, the type class itself has become representation polymorphic here, because the A here can be a representation polymorphic type. So it just expands the scope of what you can do with Haskell. There's a bit more in this proposal as well, actually, that's also implemented as well. So here, u.f, then I'm using int hash arithmetic on it. Does that make sense? This is, again, is filling out the envelope, going a little bit further.
Sorry.
Oh, yeah.
Why do you need that equality constraint on it instead of just substitute that A with the int hash?
Oh, yes. Why don't we say has field fu int hash? Well, we could maybe do it with functional dependencies, but the trouble is typically when you're doing type inference, you don't know what A is yet. And so you're trying to figure out what A is, and the way you figure out is you say, well, I can match on the F and the U. I know it's a record of type U. I know it's a field F. And A will match anything, so that's good. And then you say, oh, and now I need that A must be int hash. So it's a sort of way of staging type inference, really. It's to help the inference engine is perhaps the best way to say it. If you weren't bothering with, if you didn't need to do type inference, then you could just have put an int hash there. Okay? All good? Let's see. Oh, what else? This is a little piece. Remember those required type arguments? We said that, so now we've got to have types, things that look rather like types, but they're living in the middle of terms. In 9.10, you can't write this. I said you could, but it's not true. You have to wait for 9.12, because we have to extend the parser a bit, the term parser, to understand for alls in terms, and only later in the type checker do we convert that term into a type. So that part is only here. Okay. All of this stuff to do with required type arguments is done by Vlad and Andre, who work for Seracol, and they are an amazing pair. They really work hard on our collective behalf. We should they're not here, but we should give them a big thank you. I think they've been doing a lot in this filling out the corner space. Okay, where are we? Oh, a pet favorite of mine. So mostly I've been running around doing code review for all of these things. But this is something I've actually done myself, which finally, this is a proposal that Richard and I wrote about that says, at the moment today, you can set for a type class overloaded function, you can say specialize f colon int arrow bool arrow int. I should have written this out. That's today's syntax, right? But here's another way that you might reasonably want to write it. Just specialize f at int, right? Because you could write that at a call site. And after that, there's no real reason you wanted to write out the whole of F's signature, right, with int instead of A. You really just wanted to say the int instance, please specialize F for that instance. And then once you've got that far, you might want to say, oh, look, and I'd like you to specialize it also the case for the second argument is true. What's the big deal, right? We're specializing it for the int type and therefore the int dictionary, but also for the true argument. Right, so this syntax just lets you write out a little, as it were, prototype call to F with some for alls here to say specialize this for any value of X, but only for the case when the type argument is int and this term argument is true. Then take the whole right-hand side of F and just fill in all those things and compile it. And then anytime you see a call to F that looks like that, you can replace it with that new function. Yes.
Yeah, it should be an F in the first definition, right? Just checking. The first one should be F.
No, definitely not. Shouldn't be an F at all. Yes, of course it should be an F. Thank you very much. That is horrendous.
Does it specialize it only when you have an actual true in your source code, or does it dynamically at runtime decides if it's true, then I'm going to use this other function?
So when you write this pragma, it will create the specialized version, right?
Yes.
And then it will also create a rewrite rule that says if during simplification you ever see that pattern, replace it.
But it's static, it's not dynamic. If I call f at some point...
Yes, it's completely static, yes. It does not, f itself does not say, oh, is the argument true? If so, zoom off to this guy. It does not, no. Because, of course, inside f it's going to be testing that anyhow. But it might still, yeah. You could imagine doing that, but I'm not at the moment. But feel free. Yarrow?
Does this use the new or higher order rewrite rules in the rewrite rules that it generates? If you have like
it doesn't use higher order rewrite rules at the moment, no. But I think if you had an argument that maybe you're asking, if you had an argument that was a function,
yeah,
right? So you said f at int xg, right? Then it would specialize just when you called it on g. But
no, but I mean, if you call it on or if you write instead of true lambda x of g of x or something like that.
That's a good question. I don't know, maybe with the, this is a self-interested question, because Yarrow's implemented this. The talk you're going to hear tomorrow from Yarrow is about higher order rules, and that might actually help here. Yeah, I hadn't thought about that. Cool. So this is implemented. There's a branch with this, but it hasn't landed yet. And so the question is to race for whether I have enough cycles to land it before 9.12 gets forked. But I find myself quite a lot writing functions, and I want to write them once, but I then want to be completely confident that I'm going to get, the version specialized for true and the version specialized for false with no runtime tests. And this lets you be completely confident. Okay, where are we? So a few other smaller things in 9.12. Dropping support for 32-bit macOS. Why are we dropping that? It's because nobody uses it or something?
Yeah, I don't think anyone uses it.
Probably find 5 people here who say
and no one maintains it, and we don't have the CI resources to test it, so might as well get rid of code that no one's testing or using.
And on the profiling front, I think I'm probably understating things here by just saying profiling works for dynamically linked code. There's been quite a lot of other work on profiling, hasn't there? Do you know anything about it?
There were late cost centers in one of 9.8 or 9.10, I think, which allow...
Late cost center call centers, is that? So late cost centers means, let's see. Do you know about cost center profiling? That's where you say set cost center, SCC, the SCC pragma, and it gives you, this goes right back to the paper that I wrote with Patrick Sampson 20 years ago, but it gives you sort of lexically scoped cost centers. It's all very beautiful and nice, but it does inhibit optimization. So late cost center says, do all the optimization pipeline stuff, and then add these cost centers into the code. So it gets in the way of optimization much less.
That does mean you have less useful names for the cost centers, because names are generated by GHC. So whatever it comes up with is what you get. So you might have to look at the core to interpret your profiles.
What this cost center means, yes. Okay, and deterministic object code generation. This is, I think, some fairly big users of Haskell are very keen, particularly with sophisticated build systems, on having deterministic object code. And I think Rodrigo is working hard on this at the moment, isn't he? So, okay. Now, Cheng, where's Cheng? WebAssembly. So yes, you probably know that you can compile now to WebAssembly. Pretty good.
Yeah, right. So back in 9.6, we merged the initial version of the GHC WebAssembly backend. That means you can compile your Haskell code to a self-contained WebAssembly module that runs everywhere, including web browsers and stuff. And for the progress in 9.10, we added the JavaScript FFI extension. So that means that you can write foreign import JavaScript plus a little bit of JavaScript snippet code, and that will enable you to call into JavaScript code directly in Haskell without you needing to write any of the glue code. And it allows you to call JavaScript in Haskell, and it also allows you to export Haskell functions as JavaScript functions. And the best part is that it integrates the Haskell concurrency model with the Haskell green threading model, so that you can have like calling the JavaScript async functions like fetch, and then the Haskell thread will block until the promise resolves or rejects, but the entire runtime is not blocked. You can also have the Haskell runtime schedule other Haskell threads for execution. So that is the JavaScript FFI feature added in 9.10, which I will give a detailed talk about it tomorrow. And the next to come, one is template Haskell support. I promised a lot of people I'm going to be delivering template Haskell in like Q3 or whatsoever, but it is a very soul-grinding task because dynamic code loading in WebAssembly is pretty hard, and I've been bothered with some memory leak issues. So I'm almost there. Cannot give exact ETA yet, but I hope template Haskell can be fully delivered before the end of this year. And after that, I'm going to be implement multi-core parallelism. That basically means porting the threaded runtime of GHC to WebAssembly so that you can have one Haskell app in your browser eating up all your CPUs and CPU cores. And I hope it's for some better purpose than crypto mining or whatsoever. So yeah.
Wow. Amazing. On my laptop, the Firefox already eats up all my CPU. So Cheng, is it still true, though, that what I wrote here, that it's still a tech preview in the sense that it doesn't come in the box? You have to build yourself GHC in a particular way to get this? So yes, this
because GHC is not fully runtime retargetable yet, if you want to cross-compile Haskell code to a special target, then you have to compile a special GHC for that purpose. But if you're going to be trying the GHC WebAssembly backend, then we have the CI artifacts that you can just download and reuse all of that. And we also have detailed setup instructions on how to use those binary artifacts, which I will also give a talk about it tomorrow.
So we want to make it more retargetable. Yes. And that's another thread of work that is going on somewhere, isn't it?
Hi, I'm not too well versed in WebAssembly, but do you support dynamically linked libraries in WebAssembly, or do you build one big binary? Is it basically all statically linked?
Sorry, can you repeat your question?
Is the final binary that you build, is that a completely statically linked thing, or do you have?
Yeah, it's completely statically linked with all of your libc and whatsoever bundled in the WASM module.
So we can't yet compile GHC with plugins that run in the browser?
Plugins is a whole another story. I think Laut will give you a much better explanation because he is working on.
But without plugins, we could run GHC in the browser?
Unfortunately, the question is hard to know for now due to a lot of technical reasons.
Right.
Oh, I've just spotted Andreas sitting quietly at the back here. the grandfather and curator of WebAssembly. Thank you so much. Who else? Anybody else want to say anything about WebAssembly? Okay, so Loiter. Where's Loiter gone? Oh, where's he? Oh, there. Right. Yes. So JavaScript.
Yes, we don't have multi-core, but we can load dynamically things more easily. We've done a bit of work on it. Most of our work has been maintaining and bug fixing and small things, but some new features. GHC used to have an optimizer, which was based on abstract interpretation of JavaScript AST thing, which is about as easy and fun as it sounds. So I didn't want to replicate that in GHC, and so we have a much simpler optimizer that works almost as good, but it does not use fixed point iteration or anything. It's simple and it's much less buggy. And also, if you have C sources in your Cabal packages, they will get automatically included in your build artifacts that you get out of the JavaScript backend. Still, because the JavaScript backend targets everything running in the JavaScript managed heap, and etc., the representation of pointers is a little bit different. So what happens is if you use C sources, you get something you can call from JavaScript, but you have to write a small glue function yourself. And the glue function will basically be a no-op if it's an int-to-int function. But if there's something with pointers or arrays, then you probably have to copy a little bit of data. And that's pretty much it. That makes it a lot easier. And the other thing, we have now support for Google Closure Compiler again, which gets your JavaScript code a lot smaller than before. So with the optimizer in GHC and the Closure Compiler combined, it's basically back to almost where GHC used to be. And that's pretty much it for the JavaScript backend. Next slide. And another thing that I wanted to say, please try it, is that we now have a RISC-V native code generator. This was written mostly by Sven Tenney, and he's a new contributor to GHC. And Moritz wants to say that it's a really nice project that we can have a new contributor and make something big or something quite very usable. RISC-V is still a bit up and coming, but I think we'll see more of these things. So it's currently in the GHC master RISC-V branch or something. You can find it on GitLab. But it's close to be merged. I hope it will be in 9.12, but I'm not completely sure yet. It passed the test, so yep. Oh yeah, the names are there. Sven did most of the writing, and Moritz, who's done the ARM64 for Apple and that kind of things, he's done some mentoring.
Yeah, so it's quite a lot of work on back-end stuff happened on GHC this year to make it run on different platforms. Fantastic. Okay, now, what else is happening? So I just left a little space here because I'm expecting that some of you are working on things that you can tell us about. Anybody got anything they've been working on? At all? I'm shocked.
So this is very much in the very initial stages, but right now you might, if you're using plugins in template Haskell. So GHC only has one notion of dependency, so package is either a dependency or not, but rarely for purposes of cross-compilation, performance, and so on, compatibility, we want to separate out build time dependencies and runtime dependencies as two different things. So there's work that needs to go into designing, adding annotations to imports to suggest whether, in what scope particular imports make their values visible. There's work that needs to go into Cabal to make it differentiate between runtime and build time dependencies, and there's obviously work that needs to go into GHC to make it understand all of that, but that's something we hope to do in the very near future. So that's one thing that, yeah, is in progress. There's a question there.
This was not a question, but something that I have been a user of but didn't actually create, but it will be in 9.12, is that you can now create constraint solver plugins that are sound because they can track their dependencies.
Yeah, the issue there is that a type checker plugin might say, might be doing a proof that, I don't know, 2 plus 3 equals 5. Now that has no free variables, so that little proof is fine. But if the proof that it does in this constraint domain that it understands and GHC does not, if the proof that it is doing relies on some in-scope given constraint, like I might be trying to prove that A plus 3 equals 5, and that might be true if I have in scope a given constraint that A is 3, right? But that would not be true if I didn't have that constraint in scope. So if I was to take that little piece of code that needed that proof and move it outside of the GADT pattern match, suddenly it wouldn't be right, it wouldn't be sound. And you might get a runtime seg fault. And we did.
Yes.
Right? And
yeah.
we did. Right? So really, the proofs constructed by the plugin should record the lemmas that they used, right, that are the in-scope lemmas, effectively, as free variables of that proof. And then GHC will know, oh, this little proof depends on P, Q, and R, so I can't float it out of the scope of P, Q, and R without things going unsound.
Yeah, I just want to know that I am not the author of this. I'm just a user.
You were just the author of the thing that crashed when,
yes.
When we didn't have it. So that is, yeah. Anybody else? Yes, Matthias. Thank you, Pedro.
Yeah, so we had a talk this morning on on tracing, right? So, and you all know about this HPC Haskell program coverage that we had for a lot of years, but it hasn't received a lot of love. So I think we're working with I think David Binder is also here. So we're trying to give that some more love. But it's more tooling related, right? But so the idea is that we're going to add more runtime tracing, like low-cost runtime tracing to GHC. So if your program crashes with a head, it's probably going to integrate with this new error backtrace. But you want to be able to see like the provenance of values that were consumed that caused the error, right? Because sometimes you can just see the, it says like crashed on an empty list, but you don't know where that empty list is coming from. So yeah, so we're working on, so we have a fork where it works, but we're kind of finalizing the design of, runtime traces in error messages for GHC. But yeah, but it's still in progress. So I think that's why Simon hasn't heard of it yet.
Yeah, I also just have a small thing. It's already done, I think, since the last release of HLS, so this is relevant for all GHC developers. So GHC has these nodes, and often in the code base, these nodes are referenced, so C node and then some name. And so since the last release, I think, of HLS, you can automatically jump. So with the normal jump to definition that you can use to jump to function definitions, you can also jump to definition of these nodes in the, even if it's in another file in the project. So, yeah.
Oh, that's cool. I personally regard this as being the one of the most important but lowest tech innovations in GHC's code base. Probably around half of GHC's code, or maybe a third. I mean, a lot of GHC's code base is notes. There are thousands and thousands of lines, and I read them, I write them a lot. I read them every day, and if you ever submit a merge request, you know that you are going to get a response from me saying, can you please write a note to explain how this works? It's just sort of lambda x dot, can you please write a note? So just be warned. Sorry, you had a couple of hands up. Yes, speak.
Another thing probably worthwhile mentioning is there's a bunch of work going on to improve the integration of GHC into build systems like Bug2 and Bazel. That's work going on with Mercury, with Ian here, with Cheng is also involved, a bunch of others who are not here. Also, Zubin is involved in some parts of this. Around making it easier to get out of GHC structured information about dependency graphs, build dependencies, and so on, improving one-shot mode, and in that context also a compilation server, and yes, GHC-M, and also one-shot mode support for bytecode. I'll be talking about some of these things tomorrow in the Bug2 Haskell talk. Yeah.
Before you pass the microphone away, does that support backpack?
No.
My turn. So a few things going on with cost analysis of lazy evaluation. So a couple things. First of all, my lab mate Nicholas, raise your hand. Where are you? Hi Nicholas. He fixed HS to Coq, which is the program that translates an older version of GHC Haskell into Coq. Was that 8.10.7, Nicholas? 8.10.7 what? Yeah, that's the one it's at now. So, you know, you take what you can get. Thank you, Nicholas, because before he tried that, it was totally broken and we were all very sad. So, can I just put a name again? Nicholas Coulthard? T-H-A-R-P. No. C. You can type it. I'll go type it.
I like giving credit to the people who've done the work, right? That's what we want.
Yeah, I was just the one brave enough to come up here and say it.
That's exactly. That's it. You had a special bonus for that, yes.
Yes, thank you. So that's one thing that's going on in our lab. That's my advisor, Yao Li, is leading a lot of this stuff. The other big things are we're trying to get a formalized implementation of finger trees into our cost model. So you might have heard Liao's talk, was that yesterday or 2 days ago? I don't even remember anymore. It was about demand semantics in Coq. And so that's the next data structure we're hoping to get mechanized cost analysis for. Finger trees. Yeah. Cohen is on that paper, is on our paper too. And what was the third thing that we're trying to do is make that process automated, so it's mechanized in that there's a process that you can follow to translate functions into a version that will let you compute the cost of lazy evaluation on a particular input, but it's not automated. So it turns out that the calculus to compute that output, that new function, is a little bit more complicated than it looks, and the only person I know who can consistently do it off the top of their head is Li Yao, and that's not a very good compiler. So we're hoping to get it to the point where you can just put a function into it and press a button and give it the input that it's looking for, and then it'll just work. So that's what we're working on. Get in touch with my advisor, Yao Li, if you want to hear more about that. Or me, I'm Laura Israel. This is no, Portland State University. Yeah. Thank you.
I just want to mention a project. So we mentioned earlier that there was a WebAssembly backend that's coming along very nicely for GHC and what have you. I have a project from last year which involved actually compiling WebAssembly down into a bunch of polynomials for running as zero knowledge proof. Anybody who wants to is welcome to try and figure out how to get that to be up to the task of actually trying to run this WebAssembly backend that we have for Haskell. But it is sitting there on my GitHub account as Starkify. It was funded by a company that no longer exists.
WebAssembly to polynomials?
Yeah,
That sounds crazy. Like, you take an arbitrary WebAssembly program, you
I
spit out a
take an arbitrary
polynomial.
WebAssembly program, compile it, run it. When it's done running, I then trace the execution that it did, prove that that was correct, and then log that proof in a way that you can, so it runs in nlog n time, but then can be verified that it was correct in log squared n time on a blockchain. So you can verify that the run was correct in sublinear time.
Okay, good. He said non-committally. Anybody else? Should we move on? I've got just a few more things to wrap up. We have time? Yeah, okay. Great. Let's see. I just want to tell you a little bit about the GHC proposal process, which is the process that that leads to these number of proposals that we then end up implementing and putting into GHC, just to tell you what's happened this year. So at this moment in time, we have had, in the total history of the GHC proposal process, 430 proposals. 88 says under discussion. That just means they have not been withdrawn, shelved, or accepted. But under most of these are not in a very active state. The right-hand column, though, is the changes this year. Right, so we had 36 new proposals, of which 22 are still in that sort of the limbo state. Why does it say -9? Maybe that's because there are 9 fewer under review now than were. So that's good. We've sort of accepted or rejected those. We accepted 22, rejected none. Did we reject none this year? It was very kind. And quite a few have actually been implemented. Yes, I'm sure you will. Yes. Okay, so just to give you the sense, there's a sort of ongoing process there that's actually happening, functioning reasonably well, I think. I'm not saying that all the decisions taken are perfect there, because it's, we're just a group of people trying to do our best. And it's a big, complicated language, but it is at least an open process which all of you can participate in, and I wish you would. And in fact, let me, if I just skip ahead to here are the people who are currently on the committee. We have a kind of annual process. A couple retire, 2 or 3 people retire from the committee. Then we seek nominations, and really it's very open. You do not have to be a heavy-duty academic to join this. In fact, we specifically want people who are practitioners and who also are sort of hungry, have energy, and go and read papers and think about things, because if everyone is just frantically busy doing other stuff, they don't get enough done. So there's a shortage of intellectual bandwidth on the committee rather than intellectual. There's plenty of intellectual horsepower, just bandwidth. So I'm really grateful to these people, really grateful. I think we all should be, because essentially they're doing us a public service. But a lot of other people contribute to the debate, right? Because the debate on the the GitHub place is entirely open. But so what proposals did we accept this year specifically? Finer grain warnings about unused, at the moment, if you have a variable that's unused, at the moment it'll report everything that it's, usually read the proposal. It's a useful filling out the thing. Specialized with expressions we talked about. No field selectors. This just says you can not generate field selectors for a data type declaration with field names, and you can do that on a per data type basis. Multi-line string literals we talked about. This part, extension lifetime framework, we'll come back when we talk about stability and articulating stability goals. I'll talk about that in a second. Hasfield we talked about a little bit already. This is the making it levity polymorphic. There's a bit to do with HPC, the Haskell program coverage tool, and its TIX files. Linear Haskell is still evolving. Again, mainly filling out the envelope. This was a filling out the envelope kind of proposal from Arno. You can now, at the moment, GHC says there are 2 ways. The ways in which you can get a non-zero return code from GHC today are pretty limited. This proposal gives a slightly more flexible way to set the return code for your program. This is a fairly specialized question. Import shadowing. This is an important one for stability. At the moment, if you import a module and the author of that module, who may be somebody completely unknown to you, adds a function to it that you thereby have imported, and you have a top-level definition of your own with that name, GHC rejects your program, right? Ambiguous use, right? It's going to, well, you have to say import shadowing. You have to say some extension, but it'll be in some language edition, and you'll get it automatically. So in love, good. Right. This went through very quickly because everybody liked it. All patterns, we talked about. Oh, sometimes we have proposals that are simply amendments to existing proposals when, in retrospect, we think, oh, that design wasn't quite right, or it needs further clarifications. So if you see an accepted GHC proposal you think is not quite right, not clear, could be better, submit a pull request for an amendment. It'll go through very quickly. It's very helpful. And these proposals live a long time. You know, they'll be looked at for years. So the better they are, the better. Oh, wait. Mumble, I'm going to skip these ones, I think. These are all fairly specialized. Wildcard bind. Oh, wildcard binders in type declaration just lets you say you can use underscores in type declarations. Like if you say, if you got a, I'm going to skip it. Multi-line strings we talked about. These are the people. Yes. So that's what I really wanted to say about the steering committee process, except to say that we did spend some time this year thinking about stability. And particularly, we adopted some, we're saying we never really articulated explicitly what criteria we should use when evaluating a proposal. A proposal that, for example, breaks all existing programs, we might think it make the language better, but is that a problem? Of course it's a problem, but we hadn't really said so explicitly. So now we've written down, and you can see on the home page for the GHC steering committee, you can see the principles, and the principles include these general rules that are spelt out in some greater depth. Right, that says, and what does this mean? If it works with a version of GHC, it ought to work with the next version of GHC. That's a goal. We'll come back to it in a second. Provided you're using stable extensions. What does that mean? Well, it means that some GHC extensions, like, say, linear types, are by their nature experimental. And we don't want to immediately tie ourselves down to saying, we will never break anything, or at least we will, bend over backwards to stop breaking and have deprecation cycles. No, some features we'll label as experimental, and that means, the next version we might break it, right? Because it will change, perhaps for good reason. But stable extensions, you should know. So the idea is just so that if you're going to stray into experimental territory, we want you to know so we're going to classify all extensions by their stability. And indeed, and this proposal here defines, in fact, 4 categories. Experimental, that's what I said. Stable, that's what I said. Legacy means we don't really like it, but we're going to keep supporting it forever. And deprecated means we don't really like it, and we might well stop supporting it, but we probably won't tell you when. Right? So the difference between legacy and deprecated is a bit, is not very much, but in the end we decided to have it. Okay? So this is just to say that as a language design question, we're paying more attention to stability. And then the other thing I wanted to sort of segue into, for GHC more generally, not just the design of the language, well, also, I think there's been quite a big culture change, right, to pay much more attention to stability. So we get lots of stuff saying it's so painful to upgrade from one version to GHC to another. Who was I speaking to today that says they're still on 8.10? I was definitely speaking to somebody there. But yes, Cardano is still on 8.10. We're nearly at 9.12, right? But it's a pain to upgrade. I think this time it will still be painful, but I think it will be getting less painful because we're paying a lot more attention, So let me just point you to this page. I put a link here. We'll publish these slides. This is a little, it's only a Google Doc at the moment. I wrote it. It tries to say, what are the facets of instability? But so actually it turns out there's more than one. Some of it is the language design, maybe the language design chases. A lot else is to do with the changes in libraries, right? And also there's some issues to do with template Haskells. There are several sort of different angles. So I've written it here as a sort of multifaceted problem, right? It's not a single pain point. But the big goal is really, and I don't know, how hard can it be, really? You get a compiler, it compiles. So, your program compiles. You get a new version of the compiler. Surely it should be able to do everything the old version did. What's the big deal? Of course it should be able to compile your old program unchanged. At the moment, it doesn't for things like, but it comes with a new version of base. But there's no real reason why you should be able to use the old base API with the new compiler. Why not? Right? But it turns out there are reasons why not. It's not straightforward, but that's what this document is about. And I'd be quite interested, if any of you want to take a look at it, in which are the pain points that impact you. That is, which should be the priorities. I've said here, difficult to know how to prioritize. Which would be the primary priorities? Up to now, we've put a lot of focus on not changing the language too much, all these extensions. But I suspect that's not the main problem these days. Okay? So anybody got anything they want to... I think that's all I wanted to say about stability. Has anybody got anything they want to say about this? Because this is a complicated question, I think, with lots of aspects.
So how does stability of the language and stability of the GHC API interact?
Stability of the GHC API is another axis of stability. So for maybe everybody knows this, but you can use GHC as a library. For example, HLS uses GHC as a library. Quite a lot of programs use GHC as a library. But when you use GHC as a library, right, to say, look at a Haskell program through the lens of GHC, what is the API that you are using? And at the moment, we don't have one. We do not have a written down API for GHC. So what happens is our poor, hapless users necessarily are forced to just say, oh, I like that function, I'll use it. And then I changed that function, 2 weeks later, because I didn't know you were relying on it. So I didn't know you were relying on it. You didn't know that I was going to change it. This is bad. So we should fix the GHC API and say what it is. And that is a sort of, at the moment, an unforced thunk. That there is a sort of project which Alexis announced nearly a year ago to say, let's do that. But I think it's lacked bandwidth. So anybody who's interested in helping design a GHC API would be such a help. Such a help.
So I mean, it's sort of users of GHC as a library, but also plugins, right? Because
plugins use GHC as an API. Yeah. I would be thrilled, as a GHC author, I would be thrilled to know what API you care about. And once you start to write down the API, you think, does that make sense? It seems terribly ad hoc and messy. Let's clean it up. But until you write it down, you would never get there. So guys, this is the cream of Haskell. It's sitting right here in this room. Anybody got any other thoughts about stability? I'm surprised. I thought this would you'd all be sort of like.
I'm from Mercury, and which is a fairly large code base. But I had an effort to use the GHC head against our code base, which is over a million lines of code, and then. Actually, the experience is really good. I know there definitely the stability issue, but as we actually incrementally support the GHC head, then we actually found that the benefit is much more bigger than the cost. So this is really promising, and I just found the newer version of GHC getting better and better. So I will talk about that.
Mercury 9.12 head, in fact.
So Cardano actually does compile with 9.10, but the problem is predictability of optimization. We have something where type families are optimized slightly differently in 9.2, 9.6 and higher, and our performance team says, no, that's not acceptable. And actually there's a big difference in allocations that we get. And I think it's the all or nothing thing that you mentioned. We can't really upgrade the GHC engine, the simplifier, and the libraries. Something changes it, and then we have to dig through hundreds of megabytes of core to see where it changed, and then try to massage things in the right way or find the right GHC options. And that or
fix GHC.
Yeah, sure, but that's often not quite trivial. Like I remember the discussions of the GHC call where we know that it's very fiddly to change options in the simplifier. If something is changed a little bit, then some packages will explode, and others, if we change them the other way, then lots of packages will get a lot slower. So, yeah. So maybe, yeah, that's how I want to say.
Yeah, I was going to say in the fix, Simon, by the way, the fix is to refactor the core of the Cardano system. So you're going to have to basically completely rewrite part of the core Cardano. Now, it's a good thing anyway, because we didn't really want those type families, but we're going to have to rip them all out. And one of the things that we then have to do is make sure that all the uses, all the dependencies are also updated. We're going to have to make sure that the system still has the same functionality, and then double check the performance. So it's not something we wanted to do before we got our release out last week. Sorry, Sunday, this week.
It's funny, it's a kind of a role reversal. I'm saying you shouldn't have to change your application, we should just fix the compiler. And you're saying we're going to rip our application in pieces. Sorry, Christian. But there's something funny going on here. We should talk about it. Yeah.
So I was wondering, is performance as something that's marked as stability?
Yes.
It should be, yeah.
Yes. So it is difficult because anytime somebody reports a performance regression, our heart sinks. Well, my heart sinks because I think these things can be quite hard and expensive to find out even what has gone wrong, let alone fix. And yet, my goal is definitely for monotonic improvement in performance, but it's terribly hard to achieve.
Because I would say, let's say, since GHC 6.12, the only regression in terms of functionality on GHC has been deep subsumption. For the rest, GHC functionality-wise has always been stable.
Mm-hmm.
Maybe it's base that changes all the time, or there's lots of libraries that secretly use GHC API under the hood, which makes upgrading difficult. But otherwise, GHC has been pretty stable, right?
Mm-hmm. But performance is the unpredictable performance is the problem.
But that's the main that's the main focus of this then.
And I think the way you could help us, I think, when all of you, if you come across unpredictable performance or performance regressions, it's really helpful if you can invest a bit of effort to distill down. I know it's hard to do, but it's almost impossible for somebody who isn't close to the application to do, especially if we don't have the source code, which we won't. Yeah, yes, I know. Yeah.
I meant more the stability. Is the focus on performance, or what's the focus of this whole stability?
Thing? Like I say, I think what we want to make, I don't know, the language stable, provided you use the same language flags. The GHC API would like to be stable. You would like to be able to use old versions of base, so you're not forced to use a new version, which might force changes, which has a big carry-on effect. And we'd like performance to be stable. I wouldn't say that we have a singular focus on making performance stability at the moment. Mm-hmm. That's partly because it's so hard to get at.
But GHC proper, as in the compiler, has been stable in terms of functionality for a very long time now. So the focus must then be somewhere else, right? Either base or performance, or... What has been the unstable part of GHC?
It's actually hard to know. When I said it's hard to prioritize here, it was because you ask different people, and their pain points seem to be different.
Okay.
Right. Often it's to do with libraries, though, and the library upgrade path.
Right. So base and everything that's
often, it starts with base, and that means that forces you to upgrade base, and now you can't use some library that you depend on that somebody else hasn't yet upgraded. Maybe all they need to do is upgrade the version bound, but they're on holiday. This ripples a lot. So being able to not being forced to upgrade could be a big help. Okay. I think we should wrap up. I just wanted to just show you a couple of graphs, which I do every year. This is the all tickets is the blue line, and open tickets is the sort of tan-colored line. So at least the slope of open tickets is less, but it's still regrettably positive. But it's not. It's sort of, they're kind of like straight lines. It's interesting. It's not. Neither of these seems to be accelerating. But we're up to well over 20,000 GHC tickets. It's a big, long-lived project now. Really is. And so we appreciate that. And just reporting bugs with well-characterized reproduction cases is fantastically helpful. So, the all tickets part, this is important, right? And you are contributing to that, even if you're not contributing to fixing them. It's really helpful to have good repro cases. Here are some figures that Ben produced for the number of contributors. Now, I think the figures this year look down, but we're only partway through the year, so we haven't finished. But I think the picture here, I think it's fairly self-explanatory. This is the number of people who've made one commit, the number of people who've made 10 or more, and so forth. So what does this say? It says there's a significant but not enormous base of people who contribute directly to GHC's code base. I'm so grateful to all of these people. It's just fantastic to work with such a good group of people. But I would love more of you to contribute, and and to do that, you just become part of the GHC team. We published this. I think I told you about this last year. This is the GHC HQ sort of homepage, and among other things, it points to this subpage for the GHC team, right? And here is the GHC team. And to join the GHC team, you just send a pull request. right? That adds yourself to this table with, you know, a little bit of information, what sort of things you're interested in. And then you're very welcome to join the weekly calls. So the weekly calls are completely open. If you're willing to sign up here, and there is a consequence, signing up here means you're volunteering to do things, but then come along to the weekly call, and you will hear maybe a dozen people are typically there. It's not overpopulated at the moment, and then you'll hear the hum of the business. I mean, Loita's a regular, and Zubin, of course, is there every week. I'm there every week, and you just then you'll hear in more detail than you probably want to know what is going on in GHC land. But I just want to stress, you are very welcome. Right? This is a community project. It's not a, you know, some kind of little elite group. This is all of us working together to make this little part, you know, the little GHC part of the big, rich, exciting Haskell ecosystem. Okay, any other thoughts, questions, observations? It doesn't just have to be about GHC. It could be about Cabal, Stack, or HLS, or anything else. This is a sort of, but about the, you know, the implementation and progress of the ecosystem generally. All right then, thank you very much for all your contributions. It's a lot of fun. Actually, I spend a significant, like more than half my time, I think I probably spend hacking on GHC, and I still love it after 30 years.